As we start Chapter 8, we're going to begin with functions and equations. There are 4 terms that we're going to need to be familiar with for this section. The first one is relation. It is a set of ordered pairs. Now you can recall this when you had a coordinate plane and you had to graph ordered pairs, your x and the y. The second term is domain. It is the set of all the x values, or also better known as the input, kind of like a machine. You put in input and your output would be your y. So let's look at the domain. We have a set of relation, which is the ordered pairs of 1, 0, -1, 1, 2, and 3. The domain of this relation will be 1, -1, and 2. Then our next term, 3, is range. It's the set of all the y values, all the output values, the second number. So in the same example, the range would be 0, 1, and 3. And then our last term is called a function. To determine if something is a function is the relation in which each of the values for the domain is paired with exactly one of the range. And let me just make it simple for you. The domain cannot repeat. If it repeats, that means it is not paired with exactly one of the range. So, I have a picture and we're talking about crocodiles. And in this relationship, we've got age in years, which is our x, which is our domain, in the relation of y value, which would be their length. So you can represent the relationship between age and length using the ordered pair of x and y. So in this example we have, for 2 years, they are 32 inches. So here's your first ordered pair. When they're 4 years old, 59 inches. Now this example right here is showing the relationship between years and inches. It's showing relations between 5 different crocodiles. Here's the first one, the second one, the third one, the fourth one, and the fifth one. So in this relationship, again, the first one that was 2 years old is 32 inches. The second crocodile that was 4 years old is 59 inches. The third crocodile is 5 years old, it's 65 inches. The next crocodile is 5 years old, and it's 69 inches. And our last crocodile, he's 7 years old, and he's 96 inches. Now, looking at this relationship, we need to determine, is this a function or not? In this example, it is not considered a function. The ordered pairs, which is what I just checked here, form a relation. A relation is a pairing of numbers in one set called the domain with the numbers in another set called the range. Each number in the domain is the input. Each number in the range is the output. For a relation represented by ordered pairs, the inputs, which are the x coordinates, and the outputs are the y coordinates. So we have looking at the domain in the range. In order for it to be a function, the domain has to be paired with exactly one of the range. And if you'll notice in this example, 5 is paired not only with 65, but the 5 repeats itself and it is paired with 69. So in our next example, identify the domain and range of the relation given in the table, which shows one alligator's length in different ages. So in this example, it is one alligator's length. So let's list the domain for this table. Set of 1, 2, 3, 4, and 5 is our domain. The range would be 23, 36, 47, 61, and 73. Now, you will be asked, is this relation, is it a function? This table does represent a function because, for the simple fact that it is one alligator and his age is not repeating. It is taking each of his years and then determining what his length is. So this relation right here is considered a function because the domain is paired with exactly one of the range. The input is paired exactly with the output. Okay, representing relations. In addition to using ordered pairs or a table to represent a relation, you can use a graph or a mapping diagram. Now, I have an example of a graph here and a mapping diagram, but a table is what I also have used, something similar to this. A table for my x values and for my y values. And we'll use that a little bit later on. But in this example, we are asked to represent the relation of these ordered pairs, as indicated. So I'm going to pause the video and we're going to plot these on the graph and we'll come back and check it. So note we graphed the relation as indicated. Later on, as we get ready to represent a relation, and the function is considered a linear function, once you graph it and connect the points, they will form a line. Now in our B, in the mapping diagram, I'm going to fill those in and come back and check. So you're going to notice in your text what a mapping diagram is, and it looks similar to this. So if you're asked to illustrate a mapping diagram, it will look like this. Both of these demonstrate a function because the domain is paired with exactly one of the range. You'll notice in my output, though, that the ones repeat, but that is not what qualifies to be a function. It's only if the domain, the input, repeats. It is not a function. So again, a function is a relation, is a function if for each input there's exactly one output. In this example 3, we're going to identify if it's a function or not. Tell whether the relation is a function. So in the relation of ordered pairs, the age and length for 5 different alligators. And then B, the relation of ordered pairs for the age and length for one alligator at different times. So A is not considered a function because the 5 is not paired with only one. B, it is a function. So that's all you'll have to write, is function or not a function. So now we're going to practice. You're going to represent the relation as a graph and a mapping diagram, and then tell whether the relation is a function, and you're going to explain your reasoning. I will pause it. Come back and you can check your work. Okay, you'll notice we graphed this relation, and then we used it as a mapping diagram. You can note that the domain is paired with only one of the range, therefore it is a function. Okay, another practice. Represent the relation as a graph and a mapping diagram, then tell whether the relation is a function, and then explain your reasoning. So you'll notice in this example that I have here that we graphed the function, and then to determine if it was a function, we graphed the relation. Then to determine if it was a function, we needed to see, we could tell by the mapping diagram that the -2 was paired with 2 different numbers, so this is not a function. Now, there's another way that you can determine by looking at a graph. When a relation is represented by a graph, you can use the vertical line test to tell whether the relation is a function. The vertical line test says that if you can find a vertical line passing through more than one point of the graph, then the relation is not a function. So in these examples on the first one, you'll notice that the vertical line test, it's passing through 2 points. The 5 is repeating, so this is not considered a function. In the second example of the circle here, you notice that you do the line test. It is passing through the 2 twice. The vertical line test on this next, I'll put this as number 3. 1 and 2, as I'm going backwards, and 4. Notice the 3. It's passing through the negative 3 times. And on our fourth example, it passes by the 3 twice. So you can also use this as a pencil test and taking your pencil and carrying it over the graph to see if it passes through the vertical line test more than once. And if it does, it is not a function. Here's another example. If you were to take a vertical line test and in your notes, draw it going across, you will notice that it does not go over or cross more than 1 with the vertical line test of the domain. So this example, we'll call this example number 5. It is a function because it does not. Here is another example, number 6. It is a function because it passes through the vertical line test. Example 7. Not a function because it fails the vertical line test. It passes through here and here. Here and here. In this example, the first one, it is a function. The second one, it is not a function. Here's your y-axis. Here's your x-axis. You'll notice that it passes through here and here. Here and here. It passes through several. So if it passes through more than 1, it is not a function. So as we look at our last page in our notes, which one is not a function? So in this example, the one that is not a function is B, because it passes through more than 1 point. I'll give you an example here, here, to name a couple.